Here we are looking at higher ordered partial derivatives. So as we get started, I want you to keep in mind that with single variable functions, like y equals f of x, we can find higher order partial derivatives by simply differentiating the previous derivative. So a similar idea holds true for multivariable functions, except that each partial derivative can have two or more possible higher order partial derivatives. It will depend on the number of independent variables in that function. So to get us started here, let's suppose we are considering a function of two independent variables, like z equals f of xy. So we have z equals f of xy is some function in R3. And we also want to let f sub x and f sub y be the first order partial derivatives with respect to x and y, respectively. So in this case, there are going to be four possible second order partial derivatives. So to get us started, let's say we'll begin with the partial derivative of our function with respect to x. So we could differentiate this partial derivative with both respect to x and y. So we can say that we have the partial derivative with respect to x, and we're differentiating with respect to x. Or we would say f sub xx. We could also use our differential notation. So this would be or. We are taking the derivative with respect to x of the partial derivative of this function with respect to x. So this leaves us with d squared f by dx squared. Now, very similarly, we can take this same partial derivative, the partial derivative of our function with respect to x, and differentiate it with respect to y. So in other words, we have the second order partial f sub xy. So alternatively, we could use our differential notation and say that we are differentiating with respect to y the partial derivative of the function with respect to x, which leaves us with d squared f by dy dx. Now that's the second order partials for the first order partial with respect to x, but don't forget we have the first order partial with respect to y. So we have two more second order partial derivatives here. So again, let's say that we have the first order partial derivative of the function with respect to y, and we want to differentiate now with respect to x. So this leaves us with the second order partial f sub yx. Or using our differential notation, we can say that we are differentiating with respect to x the first order partial derivative of the function with respect to y, which leaves us with d squared f by dx dy. Now there is a special relationship between these two mixed partial derivatives, which we'll talk about momentarily. But we have one more second partial order derivative to go. So again, let's say that we are starting with the first order partial derivative of the function with respect to y, and now we want to differentiate with respect to y. So this leaves us with the second order partial derivative f sub yy. Or again, we can use our differential notation and say that we are differentiating with respect to y the first order partial derivative of the function with respect to y, which leaves us with d squared f by dy squared. So what we're seeing here again is that a function in R3 with two independent variables is going to have four possible second order derivatives. As previously mentioned, there is a special relationship between those second order partial derivatives, those mixed second order partial derivatives. And we call this the equality of the mixed order partial derivatives. So let's assume that f is defined on an open set D in R2, and that the mixed partials f sub xy and f sub yx are continuous throughout this open set D. So then we are able to conclude that the second order partial derivative f sub xy is equal to that second order partial derivative f sub yx for all points xy in this open set D. So this provides us with a nice way to check our second order partial derivatives. Do those mixed second order partial derivatives, are they equal? If your answer is yes, then that's a pretty good sign that your differentiation is accurate. So let's go ahead now and verify this equality of mixed order partial derivatives with some examples.